So we are on worksheet 12.5, number 2. So we're going to be factoring all different types of trinomials back into binomials. So the first couple are actually more of 12-4's work where we don't have a leading coefficient. So we know when we split this up, it's just going to be x's in front to create that x squared. So it saves us a little bit of time and energy. We don't need to consider that leading coefficient. So I'm breaking down 30. That could be a 6 and a 5, could be a 10 times a 3. I'm looking for factors, and they need to be something that's going to create an 11. Since these are both plus signs here, I know that this is a positive and a positive. So there won't be any minusing or negatives here, so they're going to have to add straight up to 11. So that's definitely a 6 and 5. You can double check it. X squared, 5x, 6x, which gives me 11x, and then 30, so I'm done with that one. Sliding over to number 2, no leading coefficient, so it's an n and an n. To create a 30, once again, 6 times 5, 10 times 3. So for this one now, I'm trying to make a 7, so it's definitely the 10 and the 3. Because I don't have any leading coefficients, I can drop the 10 and the 3 wherever I want. They're not going to get multiplied by some other number other than 1, so it doesn't matter. But what does matter is where I put the negative. So they're multiplying to a negative 30, so it's either negative 10 times 3 or positive 10 times negative 3. Because they have to add up to a negative, I need more negatives than positives. So I need to put the negative on the 10, positive on the 3. So I'd end up with a 3n and a negative 10n, which will give me the negative 7. Okay, now we get to number 3. Now, some people will start factoring this right away and just put the 5 and the x in there. But quick glance at this, I can factor the 5 out immediately just out of the whole trinomial, leave a leftover, and then it'll be something simple to work with after that. So this would be x squared, distributing backwards. 5 times something gives me negative 40, that's negative 8x. 5 times something gives me negative 100, that's negative 20. So I've just factored out the 5, and what that does is it gives me a trinomial that has no leading coefficient. And so I'm going to have just x, and the 5 just hangs out in front the whole time. So at this point, I don't have to worry about, again, that leading coefficient. So factors of 20 that make 8, so not 4 and 5, but 10 and 2, put them in the right spots. In this case, because there's no leading coefficient, you can put them wherever you want. The negative, because it's a negative 20, has to go in the bigger number if we're going to add up to a negative 8. So it's negative 10 and positive 2. Number 4, I see a 3 in all of these. Okay, so 3 is going to come out. That's going to leave me x squared, 6x, negative 27. If you didn't know that 3 went into 81 27 times, just divide it. 81 divided by 3. Okay, so now I have a trinomial without a leading coefficient, so easy to factor. It's just x and x, numbers that multiply to 27 that make a 6. That's 9 and 3. They need to come out to a positive, so I need the big number to be positive, small number to be negative. And I'm done there. Okay, number 5, now we step the game up. 3 cannot be factored out because it doesn't go into 22 evenly. So now we have to start dealing with those leading coefficients. So I have a 3b and a b because these can be multiplied together to make 3b squared. Some numbers, like we'll get to, for instance, say 50 or 8. Okay, there's more than one way to get them. And so I have to consider all those possibilities. In this case, though, 3 can only be made by 3 times 1. So I'm going to put the 3 here, the 1 here, and I'm good. 45, besides 45 and 1, I think 9 and 5 most often. Okay, so that's hopefully going to work. But what we need to consider now is not how do 9 and 5 make 22, but one of these is going to drop in this spot, which will get multiplied by the 3. So one of these gets times by 3. The other one gets times by 1, so it'll stay the same. And then they're combined to make a 22. So if I did 9 times 3 and get 27, and then combine it with a 5, I can get a 22. So that's perfect. So I'm going to drop the 9 out here because that's where it'll get multiplied by 3. This number will not get multiplied by 3 because the 3b gets distributed twice, and then this number gets distributed twice. So in order to get the 9 to a 27, I need it to sit in this spot and the 5 to sit here. And I do need to consider where my positives and negatives are. I need a big positive 22. So that 27 I'm creating needs to be the big positive. The 5 will be the negative that knocks me down. So it's negative 5, positive 9, which will create the positive 27. So this is my final answer. Remember, you can always double check these by redistributing real quick. 3b times b is b squared times 9 is 27b. This is negative 5b and then negative 45. These two combine to get me the 22, and I am good to go. Okay, number 6, all positives. That's nice. 3 is my leading coefficient, and so I know it's just a 3 and a p. 80, I'm thinking 10 and 8, and I got to get to 38. One of them is going to get times by 3. If I do 3 times 10, that's 30, and then 8 is 38. So that's perfect. I'm going to put the 10 here, the 8 here. They're all positives, so I'm just adding it. Double check. 30p and 8p is 38p. These create the 80, these create the 3p squared, and we're good to go. Okay, number 7. 5 is my leading coefficient. I cannot factor it out individually, so I am splitting this. 5 is a nice number. It's prime. No factors besides 1 in itself, so that's what it's going to look like. Now, 54, the number that comes to mind first for me is 9 times 6. Remember, one of those will get times by the 5 when it sits in this spot. So if I do 9 times 5, that's 45. And from 45 to 51 is 6 spots. So that's perfect. 9 here, 6 here. So I'll end up with a 45 and a 6. They need to end up here. Now they're multiplying to a positive, but they're adding to a negative. So I know they're both negative. So I'll get positive 54 through multiplication. But then out here, I'm going to get a negative 45 and a negative 6. Combines to make negative 51x. Remember, you can always run this through, double check it, it'll work. Okay, number 8. Whoa, big leading coefficient, but take a look at what I see. I can't take a 25 out of all of these, but I can take a 5. So I'm going to factor out a 5 from these 3 numbers and give myself something much easier to work with. So this would be a 5b squared, because this times this puts me back here. This would be a negative b to get me back to here. And this would be a negative 4 to get me to the 20. All right, so I'm going to leave that 5 alone now and just deal with this. My coefficient now is 5, but that's not too bad. I know it's just 5 times 1. And with a 4, it's either 2 times 2 or 4 times 1. Now, remember that one of these will get times by a 5, and then I got to get back to a 1. So as I glance at these, if I times the 2 by 5, I'm going to be at 10, and then I have these 2's. It's not going to get me back to a 5. 5 times 4 is going to be up at 20. That's no good. But the 5 times the 1 is 5, and the 4 can get me back to a 1. So I'm going to go ahead and put the 1 here and the 4 here. So I have a 5 through multiplication and a 4 through multiplication, which I can create into a negative 1. They're multiplying by a negative, so got to pick the right negative spot. One's negative, one's positive. Now, you might say, well, I need the bigger one to be negative, so let me put it on the 4. But just hold on a second. You have to consider it after multiplication. It's only a 1 right now, but it will get times by 5. I actually need that to be a negative 5. So this will be a positive 4. And a negative 5 and a positive 4 will get you the negative 1. So this is actually positive, and this is negative. All right, here's where it starts to get real tricky. I can't factor anything out. 9 does not go into 70. You could try dividing by 3, but 3 is not going to go into 70. So I do need to split this. But 9 is not a great coefficient for me because it could be 9 and 1. But 9 also has factors of 3 times 3. And so I have to consider both of these options. And then 70, I'm going to guess that we're going to end up with 10 times 7. That's just a professional guess. Could be 35 times 2. Sure, it could be a lot of things, right? But 10 times 7 makes the most sense. Just as somebody who's done a million of these, it's probably going to be 10 and 7. So we need to consider we're going to multiply one of these by 9. And then the other one stays itself, and it has to somehow become a 9. Well, 9 times 10 is 90. That's nowhere close. 9 times 7, that's 63. Still nowhere close. So I'm thinking that it's not this. I'm thinking it's one of these. And so no matter where I put the 10 and 7 here, they're both going to get times by 3 because I don't have a 1 spot here. So it can be times 3 and times 3. So I'm going to have a 30 and a 21. 30 and 21 are 9 apart. That's perfect. So it doesn't matter where you put the 10 and the 7 in this case because both of them will get multiplied by the 3n. We just have to figure out where the negative's at. So if we're going to end up at negative 9, we're dealing with what we're 21 and a 30. So if we're going to end up with a negative, I need the negative on the 30. So where is that created? That's created here with the 10 times the 3n. So I need that to be negative, and I need that to be positive. And again, if you have any second thoughts, multiply it through. There's your 9n squared, 21n, negative 30n. Those two combine to make negative 9, and this times this is negative 70, and you know you got it right. All right, number 10. Right away, I see numbers that can be divided by 5, so I'm going to go ahead and pull that out, save myself a headache, because I don't want to be dealing with this 50 up here. So now 5 times what gives me this? That would be 10x squared. This would be minus 3x. And then for 90, I believe that's 18. All right, so I can leave the 5 alone now. But I've got this 10 out front. That could be a 5 times a 2 or a 10 times a 1. I'm going to go ahead and just guess it's 5 times 2. I could be wrong, though. So if I do the 5 and the 2 and I try all my combinations with 18 and nothing works out here, then I would have to reevaluate, still with the 5 out front, and do a 10x here and a 1x here, which would also create a 10x squared up front. But I'm guessing it's 5 times 2. All right, so 18, not a great number because it could be 9 times 2, it could be 6 times 3, and it still could be 18 times 1. So we've got some work to do here. One of them's times by 5, one of them's times by 2. They need to end up within 3 of each other. So 5 times 9 gets me a really big number, right? And then 2 times 2, that's not going to work. But what if I switch it around the other way? What if it was 5 times the 2, that's 10. 9 times the 2 is 18. That's still no good, right? That's within 8. So let's try the 6 and the 3. If I did 5 times 6, that's 30, and 2 times 3 is 6. Not going to get me back here, so no good. So flip-flop it the other way. You see, I've already gone through a bunch, and none of them worked, but you can't give up. You got to keep working on it. So what if I did the 5 times the 3, if I put it right here, 5 times the 3, that's 15, and 6 times the 2, that's 12. That's 12 and 15 is perfect. That's perfect. So I need 15, so I put the 3 here, and I need 12, so I put the 6 here. So my factors are 3 and 6, but it's times and times, so it's 15 and 12. I need a negative 3, so I need that 15 to be the negative, so I end up with a negative 3. So look and try and figure out where was the 15 produced. Right here, the 5 times the 3. So I need that to be negative, and then this to be positive. And now I'm finally done. That's a tough one. Okay, number 11. So first thing I should do is check and see if something can be factored out of the 3 numbers, but there is nothing there. So I'm just going to go ahead and start splitting this up. Now because it's a 9, it could be a 9 and a 1, but it also could be a 3 and a 3. So not great. Gives me a lot of options. And the 4 could be a 4 and a 1 or a 2 and a 2. All right, so I'm going to be sliding these in. If it's on this side, one of the 2 will be multiplied by 9. The other one will stay the same. Got to create a 16. So jumping right in, I already know 9 times 4 is going to be 36, way too big. 9 times 1 would be 9, leaving me a 4. Okay, that ain't going to work over here. 9 times 2 would be 18, and I still have another 2, and that could be 16, and that sparks my interest right there. So I'm thinking that that is going to work. So I don't even need to bother over here because I think I just found something that works. So I'm going to put the 2 in the 2 here. One of them is going to be negative. They got to add up to a positive 16. So if I make the 18 positive, the 9 times the 2, and I make the 2 negative, I should be good right here. 9 times p is 9p squared. Here's 18p. Here's negative 2p. That creates a 16. And this times this is negative 4. And what looked like a difficult problem, I kind of got lucky that I didn't start over here, but it worked out. We got the right answer pretty quick right there. All right, last one, number 12. Nothing to factor out of all three of these, so we are diving right in and breaking it up. 8, not great. It could be 8 times 1. It could be 4 times 2. And with 12, it could be 6 times 2. It could be 4 times 3. Or 12 times 1, but hopefully not. So I'll start off here, remembering that one of these two is going to get multiplied by 8 in this case over here. And as I start scanning through these, the one that's going to get me closest to where I need to get 35 would be the 4. So I start thinking 8 times 6, no, that's probably too big. 8 times 2, not big enough. 8 times 4 might work. So what if I put the 4 here? 8 times 4 is 32. And what do I have left is a 3, which is going to get multiplied by just 1. And hey, 32 and 3, that's going to work. And I've just hit gold right there. I don't even have to bother over here. If it didn't work, I'd have to start thinking about this side. But it did. So I'm good to go. I'm going to throw the 4 right here and the 3 right here. That's 32 and 3. That gets me to the 35. Since they're multiplying to a positive but adding to a negative, I know they're both negative, which works out perfect. Negative 32 and negative 3, that's negative 35. All right, to the back now. Let's use this skill to solve some equations. So first thing we're going to do is factor, and then we're going to use it to solve. So not using quadratic formula. On the test, you could use quadratic formula to check your answer. But if all you do is solve with quadratic formula, you're not going to get credit. I need you doing it by factoring. So easy one to start because I don't have a leading coefficient. It's just r times r. Factors of 10 that add up to 7, they're both going to be positive. So it's 5 and 2. 5 times 2 is 10. They add up to 7. And then I just set these equal to 0. I need this whole quantity to equal 0 so that when I multiply, I get 0. So r plus 5 could equal 0, or r plus 2 could equal 0. Just figure out what r is. Minus 5, so r equals negative 5. You might even just be able to look at it and see that, right? Negative 5 plus 5 is 0. Minus 2, r equals negative 2. And those are my two answers right there, negative 5 and negative 2. Move on to 14. Again, nice and easy because there's no leading coefficient. Multiplying to 12 and adding up to 7. So not 6 and 2, that'd be 4 and 3. And because they're multiplying to a positive and adding to a negative, I know they're both negative. Negative 4 and negative 3. Multiply to positive 12, add up to negative 7. Okay, what would I plug in for x to create a 0? So this would be a 4, and this would be a 3. If I plug it in, I get 0, which then when I multiply gives me the answer. So x equals 4 and 3. If you have trouble seeing that, then run through the equations. You would say x minus 4 equals 0, x minus 3 equals 0. Solve that equation real quick, and this is what you'd get. All right, moving on now to the harder stuff. So first, can I factor anything out? No. So I need to split this. It is a 5, though, so that's nice. 5r and r is the only combination I need to worry about. The 8, probably going to be a 4 and a 2. I'm just guessing. If it's not, I'll go on to 8 and 1. But I'm going to be multiplying by 5 for one of them. And I see 5 times 4 gets me 20, which gets me super close. The 2 will get me to the 18, so I am perfect with that. 5 times 4 is 20, and then I would have the 2 to get to 18. Now notice it's negative 18, so lots of negatives. So I actually need the negatives to be the 20. So I put it here. So I get negative 20, and then this would be positive 2. So when you multiply, you get negative 8, positive times a negative. And then I get negative 20, positive 2. That gets me here, and I'm good. Now I need to know when these equal 0. This one's going to be when it's 4. You could run the equation if you need to. Add 4 to both sides. Over here, same thing, 5r plus 2. When does that equal 0? So minus 2. 5r equals negative 2. Divide by 5. and leave it as a fraction. R equals negative 2/5 or 4. You can see, obviously, I'm pretty quick at factoring. And so compared to quadratic formula, I love this. It's so much better, so much faster. But at first, this is going to probably take you longer because you're just not quick at the factoring part. So we're just going to keep practicing and build that skill. And eventually, this will be your go-to, and you won't want quadratic formula anymore because it takes too long. All right, here, got to split it, 5n and n. Factors of 4, so it's 2 and 2 or 4 and 1. One of them is going to get times by 5, and we got to end up at a 1. I kind of remember one on the front like this. So it's a 5 times a 1, that's 5. And then the 4 gets me back to 1. So the 1 goes here and the 4 goes here. And I need more negatives, which isn't actually on the 4. It's exactly like the one on the front. I need to multiply and create a negative 5, and then a positive 4 gets me back to the negative 1. So then just solve these. So minus 4. So 5n equals negative 4. Divide by 5. N equals negative 4/5. Over here, when does n minus 1 equal 0? We should know it's just 1. But you can run the equation and get 1. So it's 4/5, negative 4/5, and positive 1. Okay, 17. Can't factor anything out. I do like that coefficient up front, though. I know it's a 2n and an n. 15, I like that too. It's probably 5 times 3. Got to get to a 7. 2 times 5 would be 10, and 3 gets me to 7. So that's perfect. Put the 5 here and the 3 here. There's your 10. There's your 3. Gets me to the 7. Now I need a positive 7. So when I'm comparing those two numbers, the 10 and the 3 that got me to the 7, if I want this to be a positive 7, I need a positive 10 and a negative 3. So I need a negative 3 and a positive 5 to make the 10. Remember, you can always run these through to double check it if you need to. All right, so to finish this off, 2n minus 3 equals 0, n plus 5 equals 0. So n could equal 3 over 2. Or n can equal negative 5. You need both answers. 18. If you see it, it will save you some time. I see a 3 that fits into 2 of them, but not this one, actually, when I think about it. So 49, 3 doesn't fit in, so we're not going to be able to factor that. Take it back. So we do need to split it, but 3 is just fine to have out there because it's just 3 times 1. And 49 I like, not a lot of options. It's probably 7 times 7. 3 times a 7 will get me 21. Another 7 is 28, so perfect. 7 and 7 is going to work. And they're multiplying to a positive, adding to a negative. The only way that happens is 2 negatives. Negative times a negative is a positive. So these are both going to look like this. I would end up with negative 21 and negative 8. To make a negative 28, I'm good to go. So 3x minus 7 equals 0. X minus 7 equals 0. X equals 7/3, or x equals 7.